Welcome everyone. I'm sure everyone's had a very long day. So I'm just going to add to your pain today. Who am I? My name is Craig Moyle. I work for Mantel Group. Passions, I don't know why James put that in. Some IT stuff maybe. Netball, watching stuff, consuming things. My background, I was with NAB for 11 years, back from 2000 to 2011. Then at Computershare for 7 years. So I first started working in Azure in 2014. So just as the migration from the classic model to the ARM model started happening, so that was an interesting time. I decided I wanted to focus on cloud, so I went from working for companies to working for consultancies. So I've worked away through 5 consultancies over the last 7 years. And I've been with Mantel Group as the lead Azure engineer there for about 6 months or so. So this is me a couple of months ago where my submission got accepted. I was pretty relaxed about things. Things are going pretty good, no worries at all. This is me on Wednesday night where I realised I hadn't written anything. And I realised the bootcamp was today. So the purpose of today, we're going to talk about AKS and container apps and the role in the overall Azure landscape and the differences in terms of deploying to both, because they're different. They're completely different in the way that you approach them for deployments. So if you don't know, what is this AKS thing? What are container apps? Hopefully everybody knows what container is, otherwise we might be in some early trouble. But AKS is a managed Kubernetes service. There's quite a lot of managed Kubernetes services out there. AWS has got one, GCP obviously built Kubernetes. Microsoft's advantage in the marketplace is that they recruited a guy named Brendan Burns pretty early, who was one of the co-founders of Kubernetes at Google. So we've been able to, Azure's been able to use that leadership to probably have I'm biased, but I think we've got the best managed Kubernetes environment in the marketplace. Unlike AWS, you don't get charged for your control plane, which is always handy to save a few dollars, unless you want to go for a better ETA, of course, in which case you have to pay for that. So 99.9% SLA on a free tier. If you upgrade to standard, you get 99.95. It's got great integration with other Azure services. The pros, scales really well, integrates with Enter ID really well. Monitoring is fantastic. Prometheus is built into Container Insights. And you can pull some really good data out without a service mesh. And then once you put a service mesh over the top, you get more observability into the cluster. The cons, it's pretty complex to build and run AKS, especially for a small environment. It requires an engineering team, so steep engineering effort required to build and support. Who's running AKS here? How have you found it?
Because I also use some other Kubernetes system, I feel at least it's very easy to create AKS, and also
Yep.
I feel less troublesome.
Yep.
Sometimes I need to upgrade. Yeah. I think for both of them.
Good.
But it really requires lots of knowledge.
Yes.
Kubernetes itself.
Yep.
So you need to prepare.
Which is changing all the time, quarterly releases, and keeping on track of that can be quite complex in itself. So container apps is a serverless platform. It basically obfuscates Kubernetes from you, so you don't have to worry about the managing and building of the Kubernetes clusters, which is really handy because, as we said before, it's quite complex. It's based on Kubernetes. It's got built-in open source technologies like Dapper, Keda, and Envoy. For those that don't know, Dapper is a way of communicating with other cloud services through your application by writing standard APIs. So you don't have to write specific cloud APIs. Dapper actually translates your request for storage, for example, into an AWS storage request or a GCP storage request or an Azure storage request without even to write specific platform code. Kida is event scaling, and Envoy is proxy. So pros, serverless, no infrastructure management, lower costs from a resource, as in you guys' time. Dynamically scales, integrates really well, as does AKS. As I said, it abstracts the Kubernetes complexities, supports running on demand, schedule or event-driven jobs. Cons, there's no direct access to the APIs. Everything is abstracted through Azure. And it can lock you into Azure, but you are still dealing with containers, which can be portable. Who runs container apps here, or is aware? Cool. What do you think? Good, bad, indifferent?
Don't have to worry about Kubernetes.
Which I love. So I'm feeling opinionated on this. AKS is like Godzilla. It's awesome. There's a reason why Google invented it, because they have hyperscale requirements to run workloads. If you're not in an enterprise that has those same requirements, it's probably overkill for what you need. Container apps, much smaller and more nimble. So yeah, aren't container apps a bit shit?
I have a small question. When would
Sure.
you choose to use container apps over something like app services? Container on that as well.
Yeah, that's a good question. If your workload is purely container-based, I would use container apps because that's where development's going into. App service, you can still run containers, but you don't have as much control over ingress, connectivity to other resources, security. It's quite limited in terms of the container platform. I think, from what I've seen from Microsoft, they're kind of moving away from it and focusing more effort into supporting container apps. So I'd leave app service to running code, things that you can't run or aren't able to run in a container, and look to container apps to run containers. So container apps were kind of launched a couple of years ago. They were a bit shit at the time. There wasn't much available. But there's been a whole stack of updates to them over the last year or so. So they weren't very flexible. They used to be only HTTP and HTTPS. They didn't integrate particularly well. But now, now we've seen a lot of updates over the last couple of years. So be able to package applications and deploy them. So you can start with code, build containers and deploy. And dedicated plans. You're able to put UDRs and NAT gateways in front of them now for directing traffic through firewalls. They've got this feature called apps jobs, which are small batch type jobs that run on demand. You can mount secrets in them. Session affinity is really good. It's like if everyone's played with App Gateway, sort of a layer 7 feature where you maintain affinity with a particular app over the lifetime of connecting to that app. Additional TCP ports so that you can now expose non-HTTP applications. Environment level MTLS. MTLS is a requirement of quite a few companies to encrypt traffic between containers, and so on and so forth. So this is just probably a couple of months worth of updates from last year, from August and from November. There were some other big updates prior to that. So how can we deploy an app to both those services? AKS is all based on manifest files. Are people aware what a manifest file is? We'll go through one soon, but yeah, pretty complex. So we can deploy a manifest file via kubectl. kubectl is the control application for managing your Kubernetes cluster. You can push a manifest file via GitHub Actions or via Azure pipelines or any other CI/CD tool. And there is a preview feature with Bicep. Is everyone familiar with Bicep? It's a IAC tool from Microsoft. It supports, it compiles and decompiles from the old JSON templates. So it's much friendlier to work with because it's based in YAML. There's an extensibility preview provider which lets you deploy applications to Kubernetes using Bicep, which is pretty cool if your workflow for all of your infrastructure is Bicep. Unfortunately, my demo is broken. I've been trying to troubleshoot for the last couple of hours, but it is still preview. It is a little bit broken from what I've seen, but it is quite promising for the future. So container apps, on the other hand, there's no manifest files. We can use the CLI to upload a container. We can deploy via a Bicep file. We can use Terraform. We can use CI/CD, building from a Docker file and deploying to container apps. We can build from source code without a Docker file and deploy an existing container image from a registry, public or private. We can also integrate into GitHub Actions using the AZCLI. But the important thing is to remember is that you don't have access to container apps via kubectl. Any questions on that? Cool. All right. So, I built a demo AKS cluster. Is everyone aware of Azure Verified Modules? It's an initiative from Microsoft where they're building out modules and also patterns for Terraform and Bicep so they can be used in your deployments. It lets you focus less on creating your own modules and just consuming what Microsoft's producing. Let me show you the website. So this is the website here. If we look at Bicep, we can see there's 116 modules in there for you can consume. All the way from Kubernetes to VNets, storage accounts, key vaults, and they can all be referenced directly, which I'll show you how to do in a second. Okay, so in my little resource group, I have a VNet and I have a Kubernetes service. How did I get those? Where did my little pointer go? Come back to me, Mr. Pointer. I use Bicep to build it. The virtual network is consuming the Azure verified module there. So within Bicep, we can call directly from a public or private repository for modules. So it means you don't have to have them within your code structure. You can just reference them remotely. And it's all version controlled after the column there. So build out a virtual network 10.1, whacked in a 10.1 subnet. Then the managed cluster is just a basic cluster. It's got public network access enabled so that I can access it remotely. Generally, you wouldn't have that on. You would access the API for AKS via ExpressRoute or VPN. Yeah, we've just got a basic pool in AKS. The minimum requirement is a system pool. If you're building out your AKS, you will create a user pool as well for your app, so that your system containers and your user containers don't get put on the same nodes. It's a Linux. There are Windows options as well. I would recommend, if at all possible, don't build Windows clusters. Friends don't let friends use Windows containers. And so I just deployed that just with the AZCLI deployment group here. And I created myself a role assignment because it's RBAC integrated as RBAC cluster admin. So with AKS, you've still got the choice to use either full RBAC integration, which allows direct control over the Kubernetes clusters, or you can use Kubernetes RBAC roles with Enter ID integration. So, which still uses the local RBAC, but maps it to Enter IDs. Cool. Alrighty. You can go away just for a second. So apparently I need to be over here. So demo 2, let's deploy some basic apps using some various methods. If you have questions, just yell out. By the way, don't wait. 7.
Thank you.
Why? I really should put my mouse with me. Okay. So, come on, mouse. Let's start by deploying a container app using AZCLI. So, if you're going to deploy via AZCLI, the extension's not built in yet into the Azure CLI, so you need to add the extension before you can use the feature. And then this command literally uploads a container from the MCR, which is the Microsoft Container Register. So the name of the container, or name of the container app is this. The resource group we're putting into is this. Pick the location. Every app runs inside a container app environment. So we have to tell it to build out one of those as well. Which image to use, which port are we going to use, and we need to allow ingress from external. So container apps can be used for internal use, where you want to expose a container only to your other Azure resources or all on-prem. And that's going to produce the FQDN that we can use to test. Let's do a copy of that. Paste of that. I hate Macs sometimes. Okay, so let's just look at the resource group and make sure it's doing something. So you can see it's built out the environment already. It's built a log analytics workspace by default to capture logs from the container app. It will take a couple of seconds to run. Grab a micro sleep.
Would you put this in a pipeline, or how would you use this operationally?
Good question, James. We'll come to it. I wouldn't do anything via the command line. Except for the demos, because it's nice and fast-ish. I blame our remote Wi-Fi because it wasn't taking this long at home. For those who don't know, James and I used to work together, although work was probably overestimating what we did.
I did work and Craig looked like he didn't work. Maybe the other way.
You sold the dream and I tried to make it real.
I'm taking notes.
Boo. Yay. Wasn't that fun? Yay. Been winning. So the structure of that deployment, there's the container apps environment. The environment can run multiple container apps in it. It's got a set of settings. It's very good. A set of settings that apply to all the container apps that run inside them. And the app itself. So we're running on a on-demand plan, but you can get dedicated plans as well, which means that there's faster warm-up. You have to be waiting around like that.
Do these operate like your plans are similar to app service scaling?
Bye-bye. Okay, next, cap off the rank. We can also build and deploy via VS Code, which I was just in. Well done, Craig. So building and deploying via VS Code. There's a demo environment that Microsoft lovingly provide to us. So need to install the Container Apps extension first, and that lets you deploy from VS Code, clone from that, and all these files will be in the... Are we making the repo available, James?
Yep.
Yep, cool. So you'll be able to grab them afterwards anyway. Sign into the Azure with your with a contributor or whatever rights you want, owner, and then select deploy. Here's one I prepared earlier. You'll want a Docker file to deploy from. So let's tell it to create a new one. And it will deploy all these things. So resource group, log analytics workspace, the app environment, container registry for the container, and the container app. Go for it. Okay, while that's going away, let's go back and look at the next one. It's not even doing anything because I didn't click the right thing. What an idiot. Ah, yeah. And source code is there. And we're going to go to Australia East. And yes, save it. Right, now it's doing something. So this is going through building a Docker container using the Docker file here. Pretty basic, it's just using Alpine, the slowest car, but the fastest container. And just copying some files and uploading. Is everyone familiar with a Docker file? Now if we go back to our resource groups, we'll be disappointed. Come on, VS Code, do better. With the Container Ops plugin, you can actually get a visual of your subscription and the apps being deployed. So anyway, while that's running, we'll come back to that. Next method is via a bicep file. Not you. You, this one. Always helps you look in the right place. So this is a very basic bicep file. So we're just creating a log analytics workspace. We're essentially doing what the AZCLI did before, creating an app environment just with the consumption SKU, pushing it to log analytics, and then here we're telling it to allow ingress from external to port 80, allow insecure. Active revisions mode lets you, this only has one revision, so it gets replaced every time. But if you're maintaining multiple revisions of a container for blue-green testing or rollback, you can have multiple revisions, which means that you have the active one, but it's easy to roll back if it fails. When you wouldn't do it in Bicep, you do it in CI/CD. And it's the same container, and we're just telling it to use a quarter of a CPU and half a gig of memory. Oh look, it finished. Good job. So here's the container registry. And oops, if I don't go all the way back, here's the container app, the VS Code app. So if we want to have a look, we can see it's running here. And it's API based, so. Like that. Easy peasy. Now, so to deploy the bicep file, we're just going to run it from the command line, which I said never do, but don't listen to me. Does anyone else hate Copilot or GitHub Copilot, or is it just me?
Do I hate it or have it?
Hate it.
Yes.
My favourite bit is when it just makes up something, when it doesn't know what you're actually meaning, and then just makes up something. It looks kind of like right, but then when you try it, you get errors. Then you ask it and it goes, right, I'm just an AI. So you can see it's building out already. Let's let it go. Is anyone a Terraform lover here? Doors that way. It's fine. It's all fine. Alright, while that's running in the background, let's do the Terraform deployment. Oh no, it's done. Good. Okay, so Terraform, we've got to do a Terraform init. Perhaps if we look at the file. So there's built-in providers for, or resources in the Azure AZM provider for the app environment and also the container app. So it makes it really easy to deploy. We're on Terraform plan. We're going to deploy 4 resources, so log analytics workspace, an app environment, an app, and a resource group. So let's do that. Yes?
There's still discrepancies between Bicep and Terraform, because I remember for a long time Terraform couldn't set scalables in Terra.
So Terraform is limited by how up to date the provider is. So you need to make sure, especially when there's new versions or changes, that you update the Azure RM provider to the latest version. Even then, they're not always covered, so there might be an action in the Terraform repository. In those cases, you can use the AZ API provider to provide direct access to the API in Azure. But yeah, it's much better, but it's not as nice to configure as what the native or the Terraform resources are. The thing I do like about Terraform is that the resources in Azure RM deal with a lot of the stuff that you don't have to worry about. So they're almost like modules themselves. Okay, while that's running, let's have a look at our group. Ta-da! Another container app. You get a container app, you get a container app, you get a container app. I've just given the people what they want, James. Or even if they don't want it. Okay, this should be deploying a Terraform resource group, which it is. You can see this is, they all achieve the same thing, they're just different ways of getting there. So this takes about 5 minutes to build out in Terraform for some reason. Well, it took about 5 minutes in command line as well. So while that's doing that, let's have a look at some AKS stuff. So as I mentioned before, the AKS is all based on these manifest files, which are all YAML based. and they describe how to deploy different parts of Kubernetes. So there's the kinds, you can deploy a cluster through here, you can deploy extra nodes, services, pods directly, and configure them all through here. So it's quite powerful when you're dealing directly with the API. In Azure, some of that functionality is you can deal with it through Bicep or the AZ CLI as well. So this deployment is going to deploy a 4-container workload. It's one of the Microsoft examples. There's a RabbitMQ container, which is messaging, and there's a service that runs on top to run so the deployment handles getting the RabbitMQ there, and then the service describes how it runs. There's a front end and a product service. So if we want to deploy that, we just say kubectl apply. Ooh, actually, I'll just show that there's nothing actually running at the moment, just in case you think I'm cheating. So I've got a namespace called apps, and I can't spell get. So there's no. So let's deploy something. Okay. And we're deploying it to the apps namespace. And what am I doing here? Yeah. -F for file. And that's how you deploy. So if we look at the pods now, they are coming up. So it's very quick.
So you are confronting now with deploying all the pods to AKS, right?
Yes. Yep.
Containers obviously didn't slide in.
Yep.
Is the lack of operational overhead worth it? Like,
Yes. So they're all running now. So let's have a look for the public IP. And we should be able to go. The suspense. Boo. What isn't? Pressing, yeah. When I'm at home, I'm working on a Logitech keyboard, and the Logitech keyboard, the control is in the bottom left, but on the Mac keyboard, it's function, which is why Control-C wasn't working. So it's a combination of my own incompetence and also a different way of working. Oh no, the demo gods have got me. Well, it usually works.
I guess you might have to add the port number 32067.
That's the mapping. So it maps from port 82 to 3282 on the load balancer. Anyway. The last method we're going to look at, which is a bit broken. So there is a extensibility feature in Bicep, which takes a manifest file like this, and it will turn it to a Bicep file like this. So the update is to initialize this Kubernetes provider with the namespace and your kube config. So for those who don't deal with AKS, kube config is how you connect to your AKS. So with AKS, you can get your credentials. Yes. Actually, I'll just copy and paste it. Here's one I prepared earlier. So if we look at this file here, oops. This is how kubectl connect to the cluster without me logging in via these details. This is the front end to the AKS demo for the API. And the contexts and the certs used to authenticate. So that's based off the RBAC roles that I've assigned. The other thing is if you don't have kubectl installed or kubelogon, you can use the AZCLI to install just by install CLI. And that will install the command line utilities that you need to use. Okay, so you call this file from another Bicep file using this module. And I'm just populating the kube config, which is a base64 encoded version of my kube config as a parameter. So Bicep params are the new parameters files for Bicep. They've replaced the JSON files. I'll show you what it's coming up with. So for some reason, it can't run kubelogon in that location, and I can't find a reference to that anywhere. So that's why it's failing. Alrighty, that is about all. Where did my mouse go? Mouse, where are you? Be good. So, shall I go through the pipelines? All I can hear is yes. So, rather than deploying via the pipeline, I'll just show you how it's done. So, there's two pipelines here. One of these days I'll work out which way that goes. So to deploy to container apps, there's a pipeline task called container apps at 1, and you just fill that out. Oh no, this is around the wrong way. So that's container apps, even though it's marked AKS. This one's AKS, and you use the manifest to push a manifest file to Kubernetes. Okay. So, in summary, what's better? As a consultant, I like to have a bet each way, so it depends. AKS is really good for companies with a good engineering team that's able to support and build and keep up to date a container, an AKS environment. It's great for scaling and deploying quickly. And if you've got a lot of containers in your workloads and you need to rapidly scale them up and scale them down, and you've got the experience, then AKS is awesome. If you don't have those things, you've got a smaller state of containers to deploy, you don't have the capacity internally to be able to support AKS, then container apps are a good solution. Questions?
How would you, like, it's, for those engineering teams for like AKS, it's common to like operationalize at scale, right? Like you build that large scale cluster that runs X thousand pods or whatever. If that engineering team then said, hey, I don't want to deploy AKS, but I still want to run 10,000 pods for God knows what reason. Is there a kind of equivalent way to operationalize container apps, like as a shared resource, or is it each individual dev team still has to deploy that?
Yeah, container apps doesn't really scale that well at the moment. I wouldn't recommend it for that sort of scenario. If you're a BHP or an ANZ or a NAB or a Telstra, you're probably going to be looking to deploy AKS. If you're a NIB, is a company I deal with at the moment, probably going to look at container apps instead.
More of an organizational scale question.
Yeah, because you literally need a team of 2 or 3 people just keeping it patched, making sure that your service mesh is in place, that it's configured correctly, your Azure policy is in place, that your monitoring is in place. Because you have to control right down to your AppArm and SecComp profiles on your nodes, whereas all that's taken care of with you in container apps.
And the other question I have was, and it's maybe more, for lack of a better term, religious, was you put the AKS manifests using the bicep provider.
Yep.
Does that, I suppose, do you think that decreases supportability? Like, not everyone knows how to write bicep, but maybe more people know how to write Kubernetes, or what's your opinion?
It depends on where you're deploying from. So if you've already got your manifests in place, you probably just deploy using manifests. It's more of it's super in preview, still has been for over a year. I don't know if it's going to go anywhere. The use case I can see is if you want to deploy everything in bicep for reasons in your pipelines. So you don't have multiple steps or actions. Any other questions? Yes.
With deploying container apps, I know that Terraform's probably not your favourite, but maybe your personal favourite when if you have to go deploy something.
In terms of the ISE?
Yes.
It doesn't matter.
Or just command line.
So I'd always look to use IAC because that's my preference. It's repeatable and deploy via pipelines. And as to choice, Terraform, Bicep, whatever you're comfortable with. Any other questions?
I have a question. So our example demo, we deploy one container, right? But if we have several containers that have deployed, should we also consider managing the underlying networking something?
Sorry?
Because we know when you deploy one container app,
Yep.
there is no need to consider but if we deploy several container apps,
Yes.
they need to communicate with each other.
Yeah.
How should we design this underlying network here?
Yeah, so if you're deploying multiple containers, you'd have them within one container environment, and you would use private networking to communicate between them so that you don't route back over the internet and back in.
Okay. So pretty much like based on your experience, so how many containers should so what is the maximum number we can use just for container app this environment? Because for me, I mean, for some production environment, we deploy apps to the AKS. Maybe there are 20 pods more. The work can be
Yep.
complicated.
I mean, you can get up to hundreds with container apps. Observability is another matter because observability is going to be better in AKS with Istio or another form of service mesh. So it depends on those sort of requirements as well. So what control do you need over the communication between those containers? But as I said before, there is MTLS in container apps now, so you can enable mutual TLS encryption between containers, and there is a level of observability between them. But yeah, it's the hard one to answer without knowing exactly how your applications are structured. And I think I'm kind of out of time. Thanks everyone for your time. And yeah, have a good Sunday. Well, it's just multiple ways of deploying the same thing. I think maybe before.